There he is again. 30 days ago, the company KAIWEETS provided me with this sleek little soldering iron, and I also made a video about it. They asked me if I could make a neutral video. That's what I did, but then I thought, you could actually keep using it. So I used it intensively for 30 days, put my soldering station aside, and used the little one instead. Always with the question in mind, what can't the little one do that the big one can? That's how I made today's video, and I've also got some interesting tips and little tools to share. I'll show you those as well, and hope it didn't end up too long. Let's get started. I introduced the KAIWEETS Kit S02 30 days ago and tested it pretty superficially because I kind of had some doubts about whether it was a fully capable soldering iron. So I told myself I'll just put my current soldering station aside and use only the KAIWEETS for the past 30 days. And I approached it again asking, what can it do that the other one can? That was always my premise going into this. As I said, I'll explain that again briefly. My quick experience with daily needs for everyday use, and then I'll do some temperature measurements. I'll show a few thermal images that I created to illustrate the heat distribution. I'll give a few soldering tips for beginners, what you can do wrong or what you might want to do better. And I'll show a few more things. Among other things, my Crucible. I have the small Crucible where I always do the stress test. I'll heat it up with the soldering iron until it's liquid so you can tin it. It's a really small Crucible, but it's quite a stress test. And with the 65, we'll see how that goes with the 65 watts. It's pretty amazing that it actually manages to do that. Speaking of 65 watts, this USB charger is really awesome. You can use it not just for the soldering iron, but it even works as a power supply for a MacBook. It also works for a notebook, so it really does 65 watts. I measured it because I actually have a little device for this where I can really check the power to see what's actually flowing through there. You just plug it in here and put it in between, and then you can read it off here. I'll show you that in a second. Yeah, as for the included tips, I actually use these three that you can see here. These are the ones, and as you can see, I really wore them down quite a bit. So I really did use them a lot. And the last one would be this one here. So these are the tips I use, but I haven't really used the other small ones yet since I didn't need them and couldn't do anything with them for now. I also did a whole part of it using this power bank. That means I powered it with the power bank. So you could just say, you stick it in your pocket, let the cable hang out, and you can solder. That would even work. Just like that. So this cable that I briefly introduced last time, I only used it once, simply because I wanted to check again how the voltage behaves. It really is the case that there is a voltage between the soldering tip and ground. Voltages don't flow, voltages are present. But it's so low that nothing can really happen. If you're a little worried, you can just use these. Grounding clamps, I already showed them last time. You just put them in between here. I'm only going to do this once now. After that, I won't show it again. And with that, the whole problem is solved. That means it's grounded, and I can solder here. Ideally, you'd use a spiral cable, but honestly, you don't really need it. Like I said, I did a test with it. I also did the speaker test. I don't know if you know that one. That's where you basically connect a small speaker between ground and the tip. You can hear a faint crackling sound, which means there's some voltage present, but nothing can really happen. Like I said, if you're a bit worried about it, you can ground yourself, or if you know nothing will happen, it's fine. I actually wanted to measure it with a really high quality measuring device to see if any current is actually flowing. But there are two interesting websites where people discuss this, so I decided not to make a big deal out of it. Just don't let it scare you. All right, so like I said, oh right, that reminds me of something else. The whole thing with this cat. I've realized that it's actually not such a dumb idea after all. Once you're done soldering, just put the cap back on. Nothing happens. It would be nice though. Or maybe you could say, yeah, if there were a few holes in the front here, the heat would escape faster. But when I'm done soldering, I turn it off, or it goes into standby, and I just put the cap on. Nothing happens. The little stand really isn't usable. You have to build something yourself if you're doing anything serious. Otherwise, just put the cap on it, nothing happens. You really can believe me on this. The simplest solution is right there. I was hesitant too. Maybe just because this little soldering iron looks so stylish that you wouldn't even think it's a real tool. But it is a real tool, and I'll show you that properly in just a moment. I've really put it through its paces on small projects, and I've made some documentation and a few videos about it. All right. So now I'm going to take a measurement to determine the temperature. When you do a measurement like this, please do one thing first. Put some solder on the tip. And now you can see, I'll play it for you, the temperature distribution. I'm going to show the thermal image and put it on now. It shows 315 degrees. I set it to 310 degrees. Again. Yeah, that's a problem. Always put a little bit of solder on it, otherwise the sensor isn't properly surrounded. If you don't, it won't work the way it's supposed to. Now we've got it pretty accurate again, 310 degrees, and you can also see the temperature distribution in the thermal image. I'm going to check the temperature distribution again now by adding a bit more solder. I'll go a little higher. You'll see, it's going to run down a bit now. So it's really nicely distributed at the tip, as you can see. See? So it works well at this tip. I'll put in a different tip afterwards. And I'll do another measurement when you go down here. Let's take a look. 309, 310. I've set it to 310. There you sit. All right, I'll try something else now. Oh yeah, just remembered. Now the same thing again with a different tip. Just a quick note in between about my setup. So I've set it up. 310 degrees. Sleep time. 1 minute. That means if it's inactive, it goes into sleep mode after 1 minute and then automatically drops to 80 degrees. When I move it again, so when I pick it up, I think it returns to normal. Back up to 310 degrees in 4 seconds. I think I covered exactly how to set this up pretty thoroughly in the first part. All right, now again with the other one of the two pretty decent tips. Hold on. Okay, so why don't we go ahead and take a look at this right now? 310 degrees, well, 312 degrees, so that's pretty accurate. Now, again, for the thermal camera, so you can see once more how the heat is distributed. I'll add that in nicely later. And again, about the tips. I think the heat distribution's really solid. In my opinion, that's better than with the station, with the slightly larger station. I'll go a bit higher again so you can see it even better. So here, that's already pretty good. Like I said, setup, the part where I did it for the first time, I only went in to show how to set it up best. That's actually not nearly enough. Now you just need to set it down, just like it is here. And then after a minute, it automatically goes into sleep mode. And what I have here, I want to quickly show you again. This is what I've actually always used as flux. This is colophony. Colophony is basically tree resin. And I always dissolve it in isopropanol. Ever since then, I think since I was 13 and started getting into technology and stuff like that, I've been using this tree resin. It smells kind of nice when you're soldering. It's certainly not state of the art, but it actually works wonderfully. So I always have a bottle of it in here. And if some of it evaporates, I just add more isopropanol. So I've actually been recommending colophony for ages. There are certainly better options out there. Feel free to share your opinion. Maybe I'm behind the times. But I've had the best experiences with it, and I think it just kind of smells a bit like a workshop. All right, now let's move on to the next part. Before I do the stress test with the Crucible, let me quickly do a power measurement. I've got a measuring device back here where you can measure the power. I'll take it off now. It's going to heat up pretty quickly now since it's already a bit preheated. I didn't want to drag this out forever either. Now you can see right away. 20 volts, 0.025 amps, and very little power. If I turn it on now, it really almost goes right up to the limit. 40 watts, now it's slowly dropping down. Like I said, it was preheated. I didn't want to drag this out forever. I'll just set it down here now, and I wanted to show you a little gadget. This is the holder, or what you use for it. And I just put 2 big fender washers underneath it with a bit of weight, so you can just put it up there. So you just lay it on top, and that's definitely a good way to use it. Now I need to start the stress test, and I'll also add the thermal imaging camera again. All right, now it's starting up. Let's see what happens. I'll edit this a bit so it doesn't get too boring. I'll keep this digital timer running right here at the bottom of the screen so you have a very clear and accurate idea of exactly how long it took. Because there's still a lot it has to do. It's got quite a bit of work ahead of him. You can also see that it's not running at full power. It only reaches full power once it's submerged. That'll be over soon and you'll notice it. Then it goes up a bit more. You could speed this up a bit. If you swirl things around a little, it gets wetted. It heats up faster. I've actually tried that before, so I know that. In any case, you can get this little part done in a reasonable amount of time. But when do you actually need that? But it's basically a stress test. I've also done this with the station, and of course it's faster that way. As soon as it has completely wetted the surface, you'll notice it, and then the power goes up even more. That's just the problem. So it really goes in with almost 60 watts. The beginning is definitely the worst part. Now it's dipping in. And it really starts drawing power. Now it's really removing a lot. So with these small soldering irons, you can really get it done. The station didn't do any worse either. I actually wanted to show you that again. Like I said, this is really just a stress test to see how it works. And you'll also see the heat distribution in a moment. Maybe that's still kind of interesting. Okay, I'm going to finish this up now. We've seen the most important parts. So, everything's done. All right. Yeah, 1.5, flexible. Here's a problem, or something most people don't know. Always start from underneath. I always twist it a little bit. so we can put solder underneath because the heat rises. A lot of people forget that and heat it through and only then add the solder. No, it's just better, trust me. So from underneath and then heat it through. And that's it. By the way, that was just now. 1.5 flexible. And then do a final check. You can see it here. I'll turn it around. That's how it should look afterwards. So I always twist them if they're flexible, or I tin them beforehand. You can decide how you want to do it. But it's important to place the soldering iron from underneath, heat it through, and then bring the solder to it. All right. Like this. And now we're doing the whole thing again with automotive cable. This is 25. Just twist it a little bit. And what I do with things like this, when they're a bit thicker, is I tin them first. I'll do it so you can see it a bit better. And then, just like I showed earlier, heat it up. And there you go. It's done. And do the same thing again there. Again, you can see how nicely it flows through. Once it is thoroughly tinned, carefully put them back together, and that effectively solves the exact same problem. So now they are finally securely connected. So basically, should you always strip the cables fresh? And if they're not stripped, make them bare. Or if necessary, use a fiberglass brush to clean them up a bit. That doesn't work with flexible wires. There we have a problem. It's not that easy. But with solid wires, you can do it better. So this one's being a bit stubborn. All right, now I have another one. 1.5 solid. Same problem. First, heat it up from underneath. And then carefully apply the solder. I think you can see it like this. And strip it as freshly as possible. If it isn't freshly stripped, meaning it's already corroded, clean it off until it's bare metal. Otherwise, it just won't work. So, I hope that was another important tip. That's the thing about heating from underneath. It's just better that way. It's really proven itself. If you look here, this is exactly how it's supposed to be. With solid wire, if you twist it differently, you'd have to strip it further, and that's just difficult. So I would always do it this way. Twist it once, then flip it over, and then shrink some insulating tubing over it, so you end up with a proper connection. Yeah, what else was I going to say? I use this wire stripper here when I need to strip something, and otherwise I use this soldering iron. And yeah, I guess that's it. You can find plenty of tips about soldering elsewhere. And what I wanted to say after that, always bring the solder to the joint. Not the other way around, not before. Only put a little solder on the tip of the soldering iron to tin it, and otherwise always heat up the joint first, then add the solder, because the solder contains flux and that wets the joint perfectly. So you should always do it that way. That way you'll get nice shiny solder joints. And they are also durable. And they are also smooth, so you can't say, yes, where is the cold soldering iron? That's what you actually want to prevent. Good. Yes, that's my conclusion after the 30-day test. To be honest, I have to admit, I'm positively surprised by the whole thing, because I really didn't expect much from it. So it's an ideal entry point for amateurs. When you work with it, please really don't just use the large tips. I couldn't find any practical use for the small ones. Otherwise, it's actually a decent piece of equipment. You can basically say, I think you can handle 95% of everything with it. Unless the cables get a bit bigger, like if you're working with 10 gauge wire, for example, for batteries or something like that, it just won't work anymore. Then you need a proper, solid, large soldering iron. It's ideal for beginners, easy to handle, super quick to use, it's ready to go so fast, and also has some cool features. Features. For example, the sleep and sleep time functions, how quickly it wakes up again. So I think that's a good thing. Also, it's nice that you can just put the cap on top here, and that's the end of it. So I'm actually pretty convinced by it. Of course, it doesn't look like a tool. It just looks stylish. You might even think it's a lighter or something else entirely. It does its job. And yeah, I did this review without being asked to. But I got this device from KAIWEETS to try out. I got it with a request to do a short overview of it. What I just did was really done completely voluntarily. So just on my own initiative, because I thought it's really not that bad. So I can say that. For beginners, why not? Well, it actually turned out longer than I thought. Again, longer than I thought. I think I also wanted to talk a bit more about the voltage thing, but honestly, that's way too specific. So I'll just leave that out. I'm glad you stuck with me for so long, and I'm also looking forward to seeing you again soon. So see you soon.